number, and it's going to return something. I don't know what that something is yet. Oh, we forgot the function declaration. That's not how you spell function. So that's what's going through my head so far to solve this problem. I'm hoping some of you would do the same. Now, we know we're going to need to keep track of some numbers. Let's go back here. So what numbers do we think we need to keep track of given this little explanation of what the Fibonacci sequence is? So the next number is found by adding the two numbers before it. So we'll probably need to know what the previous number is, right?
Yeah.
Yeah.
We'll probably need to know what the next number is. And then, I guess that means we'll probably need to keep track of what the current number is, I think.
Yeah.
So I don't know what those are going to be yet. But the question is asking us, given a specific number, return the Fibonacci number in that sequence. So here's an example of what the sequence would look like. So 0, 1, 1, 2, 3, 5, 8. Given 5, it wants 3 back. So 1, 2, 3, 4, 5. Okay, so what that tells me is we're probably going to have a loop running so that I can kind of create my own sequence, and then once we get to that certain point, it's going to return the current number in that sequence. So I can then create a loop without actually knowing what I'm exactly going to be looping over now. So we'll go for, and we all know how to make a loop. So for I equals 0. I less than number, probably, and then we're going to iterate on I. So I think this is what we want to do, and then I think we'll probably return the current number, whatever that is. But I think since I, as a developer, I'm not super familiar with the Fibonacci sequence at the moment, I think even before I return the current number, what I would be interested in is actually creating a Fibonacci sequence so I can actually get an idea of what it is I'm looping over at the moment. So I'm actually going to add some extra code in here that I'm going to end up deleting at the end here. So we'll go const sequence equals an array. And I know to start, I'm always going to want to push my current number into that sequence. So I can do that straight away. Sequence.push current number. So, what would my current number be? If we're just starting off with the Fibonacci sequence, what would my current number be? Ooh, can whoever's got a screaming child in the background, could they mute if that's all right?
Yes.
Sounds like maybe there's something you might need to tend to, but all right, perfect. So maybe someone can help me with this one. So we need to figure out what the starting value of our current number is. If I look at this exercise here, and I look at what it tells me the Fibonacci sequence is supposed to look like, what is our current number going to be at the first iteration of the loop?
0.
I think it's 0. Yeah.
Yes. Yeah. You guys are all exactly right. So we know the current number on the first iteration of the loop is going to be 0. So we're going to start by pushing that 0 onto that number. Now, if the current number is 0 and we move on to the next iteration of the loop, what does that make the previous number?
0.
0, exactly. So feel free to draw on the screen as well if you guys want to be more interactive, so you can answer my question with your little pen thing. I think that could be fun. So, yeah. We know the previous number from here is actually going to equal 0, but that's going to change as we loop, and the current number is 0, so we probably want the previous number to equal the current number. Okay, nice.
I just have a small comment. I think it's nice if you have the initialization at the beginning, before the loop, previous number being equal to 0. Just because we don't know what it is. I just mean here.
So you think we should initialize previous number to 0?
I don't know, we can initialize them all to 0 just to be safe. If that, I don't know if that makes sense, but that's what I would do.
Well, let's carry on with the example because we might need to go back to that afterwards. Because now that we know the previous number, one we're looping is going to equal the current number, because we don't know what the previous number is until we get there. However, what's the next number going to be in this iteration? So if we go into the example here, if we know previous number is going to equal the current number and the current number equals 0, what's the next number?
Previous number plus current number?
The next number should be 1.
The next number, exactly. We can initialize the next number to 1.
Yeah.
Now, this is where it gets a bit funky, because I think when I was kind of looking into this and trying to figure out what the Fibonacci sequence is, it looked like a lot of people online said the answer ultimately depended on where you started. So given our example, I've taken the decision to start at 0, which means our next number is always going to be 1.
Yeah.
So to get our new number for the next iteration, this is where the next number comes in. So current number equals next number plus current number. Okay, so I think we're getting somewhere. Let's take a look. Let's actually do some work here. We'll do a console.log. Actually, we're going to, if we did that, we'd be breaking the whole rule that Alex just spent a long time telling us not to do. So what we'll do is we'll return the sequence for now, because I just want to see how we're building up this sequence. So we're not going to keep the sequence in our final result, but it's just for us to figure out what we're doing. So let's return the sequence here. And given that we know that we return the sequence, we can go const sequence equals fib. And then let's say we want to just, get the first 10 numbers of the Fibonacci sequence here. So we'll go ahead and console.log sequence. Now I'm going to do this in my console here. I'm going to cheat a little bit. We're going to say node hack your future.js. This isn't something you need to know. This is just for helping moment. So we can see that this is our sequence. So we get an array just counting and iterating. That's not exactly what we want, so we've missed a step here. So I look back at my thing, and I think the step we missed is we actually don't do anything with the next number, which is a mistake. Does anyone have any ideas of what the next number is supposed to be?
I think it depends on what your semantics is, but I would say next number equals current number plus previous number is the correct sort of logic.
Yeah, I think so too.
Yeah, I think so. But I think what is interesting here, so this is where it gets a bit complicated with the logic, and I think this is where we need a good opportunity when you're solving problems to really try a bunch of different iterations, and this could be one iteration. So you're saying that the next number actually equals the next number plus the current number, right?
No, next number equals current number plus previous number.
Plus previous number. Current number plus previous number.
And
so then are you saying, so would this be our current iteration here?
No,
or should I move this?
Line. I mean, no.
Yep.
Oh, I see. You're saying what? So there's only one addition as far as I see it. It's only one addition, and then the rest is just previous number is current number, and then you have current number equals next number.
Okay, so after I set next number equal to previous plus current, you're saying current equals next number, right?
Exactly. You're just kind of moving those values backwards.
Moving the values forward. Perfect. Let's check. So that's one example. Let's see if that works, because we can immediately validate our work. I think that's one thing that is probably the most exciting part about doing development, especially front-end development, is we get immediate validation. So I'm going to go ahead and run that code again, and let's take a look. So we get an array of zeros now, which isn't what we expected. So let's talk through what we're doing here. So we've got previous number. We don't know what that value is going to be yet. We know our next number is going to be 1, and we know our current number is going to be 0. We start by pushing the current number. and we let the previous number equal the current number. So now previous number is 0. We know our next number is going to be the previous number, which is 0, plus the current number, which is also 0. And current number is always equal to the next number. So what have we essentially done here?
Zeros all around.
Zeros all around, zeros for days, which isn't exactly what we want. So that doesn't work, which is fine. So let's get rid of this line for a second. What did we have before? So we said the current number is going to be equal to the previous number plus the current number. I think that's the case. But now we need to figure out what to do with that next number. So next number, if we actually go back to the Fibonacci sequence explanation here, the next number is found by adding up the two numbers before it. So let's take a look here. So what is the next number? So to me, that sounds right. But maybe we want
next number going up here.
Yeah.
I mean, that's kind of what.
Yeah.
Yeah.
I think next number was the current number.
Say again, Stephen?
Yeah, it's John. Akko.
John, sorry.
I said I think the next number will be previous number plus the current number. Then it will give us the number how should I say it? It will give us the number ahead of them. Yeah.
Yeah. Well, I think if we do that, then we're going to end up in the zero situation again. But correct me if I misunderstood there.
I think it's that we were doing it in the wrong order. So first you get the next number, and then this goes, and then this goes. So first you do the sum, and then you have previous number becomes current number, and current number becomes next number.
So you're saying previous number becomes next number?
No. So the first statement should be the sum, I think.
The sum. You think this should be the first statement, right?
Yes, that.
Okay. So if we know current number equals previous number plus current number, then we can set previous number equal to the number, right? Or would you disagree with that?
Well, no, what I was saying is this should be next number.
This is next number.
Yeah.
Yeah.
Okay.
I think. And then, this number is current number.
Right.
And current number is next number.
All right, let's give it a shot. Current number equals next number.
This may be wrong still, but it should get us closer.
Well, let's take a look. And this is the thing, right? Like most people aren't going to get this right on the first try, or like when you're developing things, you just kind of spitball ideas and move numbers around and test it out. So if we run this again, interesting. This is a very unexpected value. Not a number, not a number, not a number. Why did we get not a number? Well, let's talk through our logic one more time here. So next number equals previous number plus current number. So previous number isn't initialized to anything. So we're adding 0 to undefined, which means that we're setting previous number equal to 0 there, and then current number equals next number. So that means we're pushing a 0. Next number equals not a number because we're adding a 0 to undefined, and then we're setting current number to next number, and that's where we get all of these nans from. And just as a reminder, nan stands for not a number. So I want to take us back to the first iteration we had here, just for a second. So I think it's very fair to say the previous number is always going to be equal to our current number, because as we're iterating, we've already done that part in the sequence. So it's fair to say that we've moved on. We can set our previous number to our current number. And we need to do that first because we need to initialize it somewhere. Number. Now next, we know our current number. We need to iterate. This is where we're going to iterate on our current number. So I think what we need to remember in this loop is that we start counting the sequence here. So this is where we add a number to the sequence, and then this is where we can start thinking about what comes next. And this is why we can then set our previous number to our current number. So once we set our previous number to our current number, we can update our current number. And our current number is always going to be adding up the two numbers before it, which equals previous. Sorry? Sorry,
The next number is adding the previous number before it.
Exactly. So we can take current number. So this, you have to think current is going to be our next number. So if we say current number equals previous plus current, because if we actually take a look at the sequence again, so we've got 0. So these are our two starting points. This is our current number and this is our next number. So 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 2. So if we want to do that, we get 0 plus current, which makes next number equal to our current number. Because this next number is going to be the number we need coming around in the next iteration. So I'm not sure if this is exactly right, but let's give it a shot. So if we run our sequence again here, we get an error. Let's take a look. This is exciting. Current is not defined. Classic. All right. So let's try it again. I'm getting nervous here. The anticipation is killing me. I want to get this answer. So we get zeros again, which makes me think we need to add the current number and the next number.
The next number, yes.
Maybe.
Number, yeah.
All right.
No, current plus previous, I think. The next number should be previous plus current number. The next
previous
number,
plus current number.
Previous, yes, plus current number.
So you think this should be next number up here?
Yep.
Exactly.
I think, Braden, just from left to right, what do you envision is the earliest number and what is the latest? Because here you have the order previous, next, and current. And in my head, they are previous, current, and next. Is that also how you see it? I mean, in terms of indices.
In terms of indices.
Yeah, I'm talking about what does next mean in your semantics. In my head, current comes before next.
In your head, current comes before next.
I think so too. If you have to go by the indexes, then it has to start from, let's say, 0, 1, 2. So the previous should come before current, and then current before next.
Well, let me explain my semantics then. I think this is an interesting thing to come into. So the reason, I think we are coming at this problem from different areas. So if we take my sequence here, currently there's nothing in my sequence. So if we look at what the Fibonacci sequence is, I'm just going to do some pseudocode here. We know it goes 0, 1, 1, 2, 3, 5, for example, for the first few. So in my head, when we start on the iteration, we're starting on 0. The previous number before that is undefined, which is why we initialized to nothing. And we know the next number is going to be 1 based on our basic understanding of what the Fibonacci sequence is. So if I wanted to figure out what the next previous number is going to be, I would set the previous number to the current number, which is 0. If I want to get the next, so the current number in the next iteration is going to be the current number plus the next number. So actually, we should do this, right?
Wait, what is your next number? I think
so our next
number means something different in our heads.
What does it mean to you?
So, starting at the beginning, previous number is here, current number is here. Oh, guys, you got too many. Okay, I'm going to change the color of my pen. Okay. How do you change the color of the pen, actually? Oh, here we go. Oh. Okay, I will do this. This is previous, this is current, and this is next. Wait, everybody's doing different things. So what's confusing to me is this statement here. That
current number, right?
Because you should never be adding a number to itself. You should be adding two numbers to create a third number.
Right. So how would you modify this then?
So I would, depending on what you mean by current number, I would say actually next number equals current number plus previous number here.
Yeah, exactly.
All right. Do that. Next number equals previous number plus current number.
Yes, and
then current number
is
equals next number.
current number
No,
equals
no.
next number. Exactly, and previous number equals current number, but after this.
But after this.
After that.
I think we're getting close.
Yeah. So
Okay, should we give it a run? Let's give it a run.
I think it's better, yeah.
So we're saying the next number equals previous number plus current number. I'm a bit skeptical of that because right out the gate, what we're doing is setting next number to 0. And this is a solution we've tried already.
But maybe the initialization is wrong, but not the logic.
But I think let's just try it like this because this is close to a solution we've had before, but we haven't tried this.
All
So
right.
we're immediately setting previous number to current number. We're setting next number equals to 0 again. And then current number equals 0. So I think we're going to end up with zeros. There's one
I
pattern
think
we're
you're
missing
gonna
here.
end up with zeros, yeah. That's right.
So, I need to save. Hold on. Zeros.
Whoops.
So there's one element we're missing. I'm going to stop sharing my screen for a second so I can look at my answer. And then I think we'll be able to resolve this fairly quickly. Okay. So, so I'm going to try one iteration now. Oh, how do I... Let me bring Slack back. I've lost it, so I can't share my screen again. There it is. I'm going to share my screen. So we've got previous equals current. I'm actually going to paste my pseudocode here so we can just follow along together. Oh. Ah. That's what I'm going for. I want this. So when I was tinkering around yesterday, I discovered that when we start by setting previous equal to current, that gives us a way to initialize it. We want our current number in the iteration to be the current plus next, and the next equals the previous. So let's give that a shot and see. Let's see what it gives us. So we say current number equals current plus next, and then next equals previous.
Oh,
So that gives us a Fibonacci sequence.
Okay,
But why?
Interesting. I actually would. This is not how I would solve it. So to me, it's a surprise that this works. But now that it works, let's try to figure out why.
So if we start with this, we've got a previous number here. So I think the first thing we need to remember is that we're pushing our number onto the sequence, right? So the first thing we do is start our count. So we always want our current number to be on that sequence, which means we want to keep the current number in mind as we start manipulating things. So now that we've pushed that onto the sequence, we can start manipulating our numbers so that it's ready for the next iteration. So to begin with, we know that since we've already pushed our current number, our previous number is going to be our current number because we're on to the next one. So that's going to be 0, which means in the next iteration, we want our current number to be the current number plus the next number. Now, this is the part that is a bit weird because we're setting our next number to our previous number. How does that make sense? Would someone care to try and explain the thought around this, like when they're solving the problem?
I'm honestly a bit lost on how the next number can be the previous number, though.
Right. Which makes me think that it's potential that we're looking at these in the wrong way.
I think your semantics is different than what I would consider next number and current number, but it works, so I can't really argue with the logic. I would solve it a bit different, but I'm sure somewhere beneath that there is the same logic. Obviously, if it works, it's all the same logic. So
previous number is not equal to previous number plus current number.
Could you elaborate?
Previous number equal to previous number itself plus current number. I don't know.
No, we cannot do math on the previous number. Previous number is already computed. I think we want the previous number to just store an older value of the current number, which is exactly what this is doing. And the only thing I might be slightly doing differently is I would do this part differently depending on what your semantics is for current and next.
Yeah.
Bredon?
Yeah.
Yeah, I think from my own understanding, yeah, it is very, it's a technical mathematics here because when we say next number equals to previous number, it seems like the previous number is being summed up like 0 and 1 to give the next number. And as we go ahead, the previous numbers are being summed up to give the other next number. You get my point, because when you wrote it here that previous number is equals to current number, 0 is the previous number, and the current number is 1. Yeah, then we come to current number equals to current number, which is 1 plus the next number. Then when we come to next number, we say equals to previous number, which means this 0 and 1 is considered as a previous number. Then the next number is 1, and then coming again to this 2, calculating it will be like 1 and 1 equals to 2. I don't know if you understand what I'm trying to say.
I don't entirely, but I think we can all collectively agree that the semantics around setting this up is important. And I think the semantics around this is wrong, because if any of us were to come in and read this, it's totally unclear, because this is a bit confusing that we're setting the next number equal to the previous number. Like, why does that make sense?
Like jumping over 2, right?
Yeah, exactly. Which makes me... Sorry, go ahead.
No, well, I say... Yeah, it can sometimes be that when the semantics is wrong, but it's sort of 2 wrongs make a right situation where it ends up having the right result. I would say this summation, it's almost like it's... Well, we can do it this... Okay, most important thing, it works. That's the most important thing. But we should be able to explain why. And that I cannot do right now.
If that makes anyone feel better, I think these types of problems are okay to get stuck on. And I think one thing with development that has been made clear by this example is what's more important than anything is getting a result that works.
Yes.
And then obviously having something that people can understand is incredibly important. But let's work on from this. So I think at the end of the day, what I wanted to show is in solving a problem, I need to understand the problem to agree. So I know how to make a sequence now. Whether or not the semantics around making that sequence makes sense, that's fine. But that's not what we're trying to do with this function. What we want to do with this function is, given a number, we want to return that slice of that that place in the actual sequence. So given 5, 1, 2, 3, 4, 5, I would want to get back 3. So let's actually run our sequence again. If what have I given it? So let's give it 5. Or no, actually up here. So 5. And let's run through that again. So given 5, we get 1, 2, 3, 4, 5. Okay, so we want to return current number. So I think if we just comment out our sequence and then we return current number, that should give us 3. But it gives us 5. So why does it give us 5?
That's the next number after that. That's because of the semantics. So you probably want to return next number.
All right, let's take a look at next number. Three. So that kind of helped us catch a problem a little bit there, right? So maybe current number should be next number should be current number.
If you swap them around, then it will all make sense.
So let's do that.
But
So we're gonna
in a safe way.
Oh yeah. So we're gonna call next number current.
Yeah, I think that's a good way.
And then we're going to call current is going to be next. So let's see if we still get the same result.
I think this will work, yeah.
Yeah.
And also, I would say right here, instead of returning current, you can do that, or you can return the last element of the sequence. It will work just as well.
We could. Well, the idea behind this is the sequence was here just so we could track the sequence. So we don't actually need the sequence at all, remember? So we're simply creating the loop, getting to the end of the part of the sequence that we want, and we can delete this. Yeah, you're right. So in theory, this would all we would need to solve the problem. But at the end of the day, what I'm hoping was illustrated is that sometimes to solve a problem, you need to kind of throw some pseudocode in there. So you might need to solve a different problem before you can get to the problem that you wanted to solve. So you can see we created this sequence so that we could actually see what a Fibonacci sequence looked like. And then based on that, once we narrowed it down to the smallest iteration we could, at that point, then we could get to the actual scope of the problem we're trying to solve, which is returning the final value of the Fibonacci sequence given our current iteration. So I'm going to go ahead and share this in the channel here so that you guys have this example to work with if you want to return to it in the future. But I think now, because we spent quite a lot of time on this, now would be a good time to actually try some of the exercises on your own. But what do you think, Alex?
Yeah, I think that's a good idea. It's kind of a good time for a little break, perhaps. What I was going to do next is do the FizzBuzz exercise, but I think it will be too much of us mentors talking if I do that right away. So my intention is to go into this exercise, but for now, we should take another exercise that everyone else can work on. So let's see. Yeah, let's take this exercise here for the students to solve. So we split up a little bit, and you guys start on this, and then we come back maybe in like 5 minutes. And if you have any questions, post them on the chat. So that we can follow up and work with that. All right. So I'll keep the call on, but I will stop recording just for a second